Okay guys, we're going to go over just some of the intro chapters to the urinalysis, and most of this is just a review of the anatomy, and it's a brief review as you should have done this before, but you can follow along in your packets and fill in any blank lines that you see. So as we're starting to talk about urinalysis, obviously what we're looking at is the kidney, the ureters, the bladder, and the urethra. And remember, we got two kidneys, right? The right and the left. We have two ureters that go down from that renal pelvis to take the urine down to the bladder, and the single tube from the bladder to the outside, which is the urethra. It is the kidney itself that regulates how much urine is being produced, so obviously kidney dysfunction is going to affect the urine output and what's in the urine. We can certainly adjust some of these things by how much fluids we take in. Obviously, if you take in more water, you take in more fluids from food, you're going to see greater urine output. Just remember that the nephron is the functional unit of the kidney, and there's about 1 million in each kidneys. I'm not going to go through all of the components of the nephron, as that is something you should have done in anatomy. But there are 3 basic processes by which we turn all of the stuff in our blood system into fully formed urine. So let's talk about first with filtration. And filtration just refers to taking out larger particles, smaller particles, right from the blood, including some water, into those nephrons. And it's not going to stay pulled out of the bloodstream, as we filter out most things from the bloodstream as they go through the kidneys. But what you can see from the next slide here is that we pull out primarily water, ammonia, electrolytes, so sodium, potassium, magnesium, and such. We will pull out glucose, although you should not see glucose or amino acids, which are protein particles, inside the fully formed urine. You may see some creatinine and some urea. So all of these things initially upon entering the nephron are going to be filtered into the nephron and out of the bloodstream. The vast majority are going to do step number 2, which is reabsorption. So we filter through our kidneys about 180 liters of fluid per day. That is certainly not the amount that we are ultimately urinating, which is only about 1 to 2 liters, right? So most of what we actually pull out of the bloodstream gets reabsorbed or put right back into the bloodstream. All right, so the body's going to hold on to everything that it needs, and the only stuff that's coming out into urine is the stuff that we no longer need. So if you have excess of anything, so you ate a high salt meal, you should expect to see, right, some of that excess sodium inside of the urine. Now, we don't actually measure for that, as that's not a big deal, because that is the location where it's safe to get rid of those excess things. If you drink more fluids, you would expect to have higher levels of urine output, because we don't need all of that inside of our bloodstream and inside of our body. Therefore, anything excess is going to be urinated. If, however, we are dehydrated, don't drink a lot of fluids, you would see really low urine output, right? Because our body needs to hold on or to reabsorb all of that fluid to maintain our blood cells, the proteins, and other body functions. Glucose is kind of its own interesting thing. While it does get filtered out initially in the nephron, it is what we call a threshold substance, meaning if you are non-diabetic and your glucose systems are working properly, that glucose should all be reabsorbed and you should see no glucose in the end product of urine. However, if you have blood glucose concentrations that are routinely higher than 180, it's going to be so much that the body essentially doesn't want that back, right? You already have too much in the bloodstream, and so your body's going to take this opportunity to keep it out of the bloodstream. And so once blood sugars are hitting over 180, you are going to start to see some sugar in the urine. Certainly we'll talk about how this is really an indication of diabetes, as your blood sugar should be below 180 if your body is working properly. The last process that we use to form urine is something we call secretion, and secretion happens at this distal convoluted tubule. So if we take a look at the nephron itself, right here is that glomerulus with the Bowman's capsule, a glomerular capsule that pulled everything out. You had your proximal convoluted tubule, your nephron loop, and your distal convoluted tubule. And so it's this distal convoluted tubule and the collecting duct that we are talking about. All right, so when we talk about secretion, we're talking about some ions, but we're also talking about a lot of medications. So things that really should not be in the bloodstream will get directly put into this distal convoluted tubule and this collecting duct portion, and then it will be eliminated through the urine. So urine composition is about 96% water and about 4% other, as long as you stay relatively hydrated. Some things you should never find in urine and would indicate some abnormal problems would be any type of red blood cell, white blood cells, fat. We just talked about glucose. We'll take a look at casts later. Bile, which is a byproduct of the liver and the gallbladder. Acetone and hemoglobin, which is a byproduct of red blood cells. All right, hopefully that's a good review of some things that you have previously learned about. When I meet you in class, we'll talk about the rest.